right, well, welcome. We're going to continue with our database design and JDBC. Last time we left off with, let's see, where were we? So just to review what we were doing, the JDBC is an API that allows you to programmatically connect to a database and process data, pull data, and save data, and persist data is what we call it. Most languages have some support for doing this. With Java, it's a JDBC API. It's a perfect illustration of dependency inversion, where you're not writing code that connects to a particular database like MySQL or SQL Server or something like that. You're writing code that connects to an API. That API that we looked at really briefly last time was a connection, a prepared statement, and a result set. There are a lot more classes in that library, in that API, but those are the ones that we're going to focus on. And then vendors like Oracle or IBM or whatever, they provide a driver that conforms to that API and implements that API. We showed how to install the one for MySQL produced by Oracle. There are also ORMs, which we might look at as an advanced topic if we get to it, where you can go ahead and annotate your POJOs, your Java objects, and make a connection to the database, and then you don't have to write any JDBC code at all. The framework takes care of it for you. The basic process, remember that we are online, so if you have any questions, go ahead and post to Piazza. The basic process is that you create a connection to your database. You need a username, password, and of course URL. You create and prepare your query. You prepare the query, and then you execute the query, and you get back a result set. Then you need to make sure to clean up your resources. So let's go ahead and take a look at what we were looking at working on last time, from top to bottom here. We've got our username, password, and URL. We create our connection here, and then we have a select star here from person. We have a prepared statement, our result set, and we prepare the statement. We execute the query, get back the result set, and then iterate over that result set. Remember, the rs.next will actually advance it to the next record, and return true or false depending on whether or not it's pointing to a valid record. Yes, true, 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 and then when it gets to the end of the result set, it'll return false. Right? For each record, you go ahead and process that record by pulling out the individual data elements. In this case, we've got a person ID, a first name, last name, date of birth, and when we marshaled that date of birth into an actual local date. Then we created the person and added them to a list and returned that. I'm going to actually clean this up a little bit, and I'm going to collapse it all down to just one big try-catch here, right? So that we don't have multiple try-catches. So I'm going to put the connection set up within this try-catch, and then I'm going to take that connection close, and I'm going to go ahead and move it up to the same block up here after we're done. But I'm also going to draw your attention here to the fact that, I'm sorry, I don't know if anybody knows where the hell the switch is. I looked all over the room and I could not find it. And there's nothing on the controls here to actually control it. So, but otherwise you can go ahead and look at that one. All right. So anyway, I was going to go, I'm drawing your attention here to the fact that we've closed the connection down here after we've made it. We also have this prepared statement and this result set, which are holding on to resources both on the server and locally. So what I want to do is I want to close those as well. But I want to bring your attention to the fact that you should close them in the reverse order that you made them. So if you have a connection, that connection gives you a prepared statement. That prepared statement gives you a result set. You need to close it in the reverse order. So rs.close, ps.close, and then finally the connection.close. In more modern implementations, just simply closing the connection will close everything that it's responsible for, but you're rolling the dice in that case, so be more explicit about it. You can also check to make sure that they're not already closed, right? rs is closed, right? And then if it's not already closed, then go ahead and close it so that you don't close it twice or something like that. Really old implementations resulted in a MySQL exception being thrown if you tried to close something that was already closed. but it doesn't seem like that's an issue anymore. Okay. All right, so to pick it up there, let's go ahead and continue, right? So there's this nice function here that loads persons, and over here when I load the people, and I'm gonna go ahead and get rid of this for a second here, and print them out, it's a CSV data file loader here, database loader. There we go. That's what I want from last time, and let's go ahead and run that. There we go. I'm getting, Grace Hopper, Alan Turing, Margaret Hamilton, et cetera, et cetera, et cetera. But what about their emails? Right? So for person P in the collection people, everyone, right? System.out.println P. If I just go ahead and print them out, of course, my toString method here is not including any of the relevant details. So let's go ahead and solve that now by going over here to the person class and updating the toString method here. What I'm going to do is I'm going to, for convenience, because I know that I'm looking ahead here to the database, I'm also going to print out the person's ID. So this dot person ID and this dot person's emails. Where we go? There we go. And I'm going to format that as a string as well. So now let's run this again and get all that relevant information. We've got Grace Hopper, Alan Turing, et cetera, just like we would over here if we actually ran that query in MySQL Workbench. We're getting the exact same data here, except that I don't see any emails over here. Right? Let's go ahead and rectify that. Let's come back over here and think about where this needs to be done. So I've loaded up all the people. I now need to go ahead and look at the email table. Should I do that here? Grab, load all of the emails for each person, ... Should that go right here? Probably not. So should I come over here to the database data loader, and should I make another public void load emails of people, right? And I'll take a list of people, and then within this method here, I'll go ahead and do that. Right? That's getting a little bit better, but that's kind of what's called a leaky abstraction. Think about it from the perspective of the demo over here. I wanted you to load the people, right? You loaded the people, but not the emails. To get that, what I have to do is I have to say, load the people, take it, and then give it back to you in order for you to load the emails, right? That means that you've leaked out relevant information about how stuff is done by not doing everything. Right? So no, it doesn't belong into a separate method. It should be done where? Probably somewhere in this method. I'm going to load the people and everything that's relevant to them. Emails, maybe their accounts, but we won't go that far with this demonstration, et cetera. Right? So I'm probably going to want to load it somewhere in here. Let's go ahead and get rid of this for now. Okay? Let's think about where we should do this. Could we do it here? Could we do it here? Right? So for each person, once that person has been created, we can go ahead and load up their emails, right? Or once every person has been loaded up, right? Everyone has been added to this everyone list here, then we can go ahead and do it for each person again. Right? Half a dozen one, 6 of the other. Right? What I'm going to do is I'm going to go ahead and do it right here. Okay? Now think ahead. How many lines of code is this going to be? It's probably going to might be another connection. It might be another prepared statement, another result set, because you're going to get the emails, you're going to load them up, and then you're going to add them to that person. At least maybe a half a dozen lines, maybe a dozen lines or so. Right? When you've got something like that that's a dozen lines or so, what should that be screaming out to you? Make a method. Right? So if I say add or load emails, and I pass in person here, right? That's then I don't have to worry about it, right? It's that function's responsibility. So let's come back up here and actually make that function. So initially I'll make it public, void, and load emails of that person P. There we go. Okay. Now before I get started here, should this be public? That's kind of going back over here to this design, and once you've loaded up the people, okay, for each person, I'll go ahead and say that dl.load emails and then pass in the person. Right. Again, it's a leaky abstraction. You should be loading up all the persons and all of their data, including email. Right? So I'm going to come back over here, and I'm going to I do want to separate this out because I want to organize my code. But one way that I can make sure that I am not adding this to the public interface is by making it private. Right? Okay. So the 4-step process. Create a connection to your database, prepare your query, process your results, clean up your resources. Right? That's going to be very, very close to a cut and paste. Right? Here we go. I'm going to cut and paste all this stuff. Right? Cut, paste, username, URL, password. Cut, paste the creation of a query, of a connection. Right? Should you be cutting, pasting, cutting, pasting, cutting, pasting, cutting, pasting? Probably not. Right? And that's why in your project you are highly encouraged to create what's called a connection factory, a class that is responsible for creating connections, right? And then storing all this stuff in one place. Because if you mess up and change your password, you should be only have to change it in one location. Okay? All right, but I will go ahead and for demonstration purposes, just go ahead and select this stuff right now. So now this is not selecting a person, right? We've got the person already loaded. What do I want to select? Let me pull up our ER diagram here so that you remember what it looks like. There we go. So once I've got the person, what do I need? I need all their emails. Well, I've got the person ID, don't I? So all I need to do is select everything from person or from email, right? Where you're looking for a particular person. Right?
Where a person ID.
Yeah, exactly. Now this is where having multiple screens, right, 3 or 4, at least 2 screens, 4 screens, 3 screens, 3 screens, 4 screens is a lot better for developers. Why? Because you can go ahead and have MySQL Workbench over here, and then that's where you actually write and troubleshoot your queries. So let's go ahead and select everything from email, but that's going to give me all the emails, right? Grace Hopper's emails, Margaret Hamilton's emails, and then Donald Newson emails. I want it of a particular person. So as you suggest, let's go ahead and go with a where clause, where person ID. And let's go ahead and go with Grace Hopper first here. She's person ID 10. Right? How do I know that? Because I hard-coded my test data up here. Right? There, now I'm only getting her emails. Okay? So now that I've troubleshot this, or at least I have a start on it, I'm going to cut and paste it over here and maybe adapt it. My first adaptation is to get rid of that superfluous semicolon. Right? All right, so that's what I want for that one particular person. Let's go ahead and cut and paste the rest of this stuff. There we go. Again, you should not be doing this, right? You should be rethinking how to separate this stuff out. Now, certainly the URL, username, password, and probably the creation of a query, that can be done in a connection factory. You will be really, really tempted to say, well, wait, I'm making a prepared statement, I'm doing a result set, I'm doing all this stuff over and over and over again. Maybe I can go ahead and just write one function to take care of all that for the rest of the time. Don't do that, right? That's going too far. I don't know if I've got an acronym for that. You've over-engineered something. What is there an acronym for it? Not you ain't gonna need it, but if you want something like that, then that's where an ORM comes in. An ORM, at that point, you're just reinventing an ORM, right? We might look at that later. Anyway, we've got our connection. We prepare our statement. We execute our query. And then instead of pulling the records for persons, we just need the address, right? Address. Remember what it looks like over here. It looks like an email ID, an address, the actual address, and the person ID, but we already have the person ID, 10, right? Now you could, at this point, say, oh, okay, well now I do need an email class because there's something more than just a string. There's also a foreign key and a primary key. So maybe you do want an email table, right? That's up to you. But otherwise, I will just simply get the address. And then I've got the person, oops, not all of it. I've got the person, I will go ahead and add their email address. There we go. Result set close. Once you're done with it, ps.close, con.close. Let's see if that works. And it does pull emails now, but it's all pulling all of Grace Hopper's emails for everybody. Hopper, Grace at hopper.net, for Alan, for Margaret, for Donald, and Joe. What was our problem?
You hard-coded 10.
I hard-coded 10 here. So you might be tempted to say, okay, well, not 10, but whatever this person's person ID is. So I'll go ahead and go with plus p dot get person ID. It looks like I need a getter for that. So 1 second, and we'll talk about why this is wrong. Absolutely wrong. Public int get person ID, return this dot person ID. There we go. And now it seems to work over here, right? Or at least it'll compile. If you find yourself using any concatenations whatsoever for any strings, for any database interaction in any language, you are doing something wrong. You are opening yourself up to what's called an SQL injection attack, right? The classic example is going to be little Bobby Tables. Did we look at him? So XKCD, little Bobby Tables. And here we go. Exploits of a mom is what it actually is called. There we go. So this is your son's school. We're having some trouble, computer trouble. Oh dear, did he break something in a way? Did you really name your son Robert and then a single quote and then the rest of his name is a SQL command to drop the table of all students, right? Oh yes, little Bobby Tables we call him. Well, we've lost your school records, hope you're happy, and I hope you've learned to sanitize your database inputs. That's what's called an injection attack, right? An injection attack allows you to, well, if they're using string concatenation, I will go ahead and formulate a string so that when you concatenate it together, it's now 2 SQL statements. This one that gets executed, who cares? And then the one that you formulated to get executed. In this case, it's dropping the table students, right? And by the way, they shouldn't have named it students, right? We do not pluralize tables, right? And they're also using old school all uppercase here for their statements. So they made a lot of mistakes here. The hyphen is a what? Comment, right? Because once you've concatenated, if there was anything after it, that comment now ignores everything after it, and that's why they formulated it like this. This is still the #1 way of attacking websites. Instead of entering your username and password, you enter in an SQL injection attack and see if they are, and as a probe to see if anything's going on. You don't drop a table because what you want is you want that data. So you try to probe the system to see how, if they've not sanitizing their database inputs, and they're using straight up string concatenation. Now it's not that big of a deal because this is just an integer, and so you could imagine that if this were like a string or something, and it was the result of a web form or something, then it would be a real problem. So what we're going to do is we're going to not make that mistake, and we're going to parameterize and sanitize our inputs here. The question mark is a placeholder. It is a variable that is going to be changed. Just like when you use printf and you use like %s or something like that, that's a placeholder for printf. This is a placeholder for SQL, right? Or for JDBC, I should say. Now what we're going to do down here is when we prepare our statement, we also need to set this value right here. So to do that, I'll go ps.setInt. There we go, because it is an integer. The first one, oops, and I don't know where that came from. The first one, and then we'll set that to p.getPersonID. That's the proper way of doing it. The reason that you do it like this is because if there's a special symbol, like say a single quote, that will go in and escape it. Now it turns it into a / single quote, so that it's no longer an SQL injection. That if you try to put in an SQL injection string as a username or something in a web form, now it'll actually treat it as that is your actual name. It's not actually going to end up running that on the server. Right? Every year, like at Corn Hacks or like programming competitions, you will have at least one team that, what's your team name? And then they try to make it into an SQL injection attack, right? As a joke, thinking, I've never heard of an actual, programming contest that was brought down by it, but you immediately recognize it as an SQL injection joke, right? All right, so let's go ahead and do this.
Is it one
Oh, yeah.
base counting? Like you start at 1?
Yes. Oh, thank you. I forgot to mention that. Unfortunately, it is. It's one base counting. So if you've got multiple ones, like and foo is equal to whatever, and bar is equal to whatever. Now I've got 3. The first one is 1, 2, and then 3. Unfortunately. You can get confused really quickly when you're going to insert data and you've got 5 of these things. What was the order again, right? And that's where an ORM comes into play. A more modern solution would have what are called named parameters. So for example, instead of this mysterious question mark, you would actually name it person ID, right? With this colon in front of it. Now that's a placeholder for JPA. Right? Unfortunately, JDBC does not support that. Okay, it's too old. Right? Again, we live with the mistakes of the ancients 25 years ago. Right? All right, so let's go ahead and run this and see if we now get all these correct names, and we do. There's Grace Hopper. Alan Turing did not have any emails in the database. So what ended up happening was that this result set was immediately false, and so this while loop never got executed, but we went ahead and closed everything anyway. Right? Then Donald News 3 emails, and then Joe Unix doesn't have any emails either. Okay. Excellent. Note here that I am opening up one connection, and then for each while loop, I am opening up another connection. Okay, when I call this load emails, that one opens up a connection. If I had, say, 50 people, and I forgot to close the connections in that one method, right, what's going to happen?
You got 50 connections.
50 connections, but that's not allowed. The server down in Lincoln allows you up to 30 persistent connections. When you open up 30 and you don't close them, you go to the 31st, that's the end of the show. It dies. Right? It is rejected. It'll result in an SQL exception, and I don't think that it'll happen here because we don't have enough people. But I've now got open connections that will be killed after 5 minutes, right? Thankfully. But you might, if you open up 30 connections and they don't close and they don't actually reset after, then you'll have to wait 5 minutes. And if the server screws up and still doesn't close them, you might be putting in a ticket to the manager to close everything. Right? And it has happened before. Right? So make sure you are always, always, always closing your connections, closing your resources. You will run out. Right? Okay, I think everything's fine. Yay. You know what? That was such a useful thing. Let's also think about other utility functions that we could have with just people. Right? What if I wanted to say private person load, or not private, let's go ahead and make it public because everybody wants access to this, public person load person by ID. Right? And then int person ID. What would that look like? Let's just sketch this out. We may not necessarily do this entire thing. Right? So it would look very much like load all the persons, except that I wouldn't have this query. What would I have instead? Where person ID is equal to that thing. So I don't know, it's easy enough. Let's go ahead and do it. I'm just going to grab this thing here. There we go. So there's my connection. I want everything from person where person ID is equal to parameterized. We will go ahead and prepare the statement and then ps.set int to one of person ID that is given as input to this function here. Right? Process the results. Do we need the person ID? Nope. So let's go ahead and get rid of that. We don't have everyone. We will create that person and then return that person. Should I go ahead and return P right there? So we've loaded up this person's data, including their emails. Should I immediately return it inside this while loop? No, why?
You don't close.
I end up not closing anything. So be careful, right? Don't just willy-nilly return things, right? Make sure that you are returning it at the correct location. And that means up here you have to have person P is equal to null initially, and then down here, we say P is equal to that thing. There we go. Let's test it over here. So I'm getting all these people, and that's working out great for me. Let's go ahead and make another person. P is equal to, what was it, DL dot load person, not person. Oh, you know what? It's not working because that needs to be part of the, I think we did an interface here. So we're going to have to add that to the interface so that it recognizes it. There. Now, of course, the CSV file data loader doesn't make any sense for that anymore because you're not loading up a person from a CSV file by their ID. So now maybe you need to rethink what exactly needs to go into my interface. Right? We'll go ahead and ignore that for now, though. So I want to load up that one particular person. Load person by ID. I don't know, 42. There we go. And then let's print that person out. System.out.println. Okay. I'm just going to get this to compile. So I'm going to go ahead and get rid of that. And that. There we go. And ignore it. Right. Let's run it. Is there a person with person ID 42?
No.
No. So how do we handle that situation? Right. Remember all the people over here. Select everything from person 10, 20, 30, 40, 50. So how do we graciously handle that situation? We're kind of handling it right now, right? It's null. You ask me for something that doesn't exist, I will give you a value indicating that it doesn't exist. What's an alternative?
Just say like, this person does not exist.
Yeah, so what, for example, I could change this instead of iterating over this one thing that I'm expecting, if not rs.next, right? That means that they don't exist. I could throw a new illegal state exception, right? You asked for something that does not exist, right? So I could throw an exception, right? Or like I've done here, I could end up returning null. Which one do you like?
The first one gives you more information.
This one right here?
Right.
Okay. It also means that now you have to handle this situation, you're going to be writing a bunch of try catches. I'm not forcing you to do it because this is not a checked exception, but yeah, that's one way to go. I'll go ahead and leave that in there. Not all of it, not that. Just so that you know that that is one possibility. But now that has me rethinking this while loop right here. Remember, we're only expecting at most one person. That person may not exist, but should we have a while loop here now? So if that person exists, then we'll go ahead and pull that data. Otherwise, we'll go ahead and throw your exception that you proposed. Right? There. Right? But what happens if we've got multiple pieces of data? Else if rs.next. So let's walk through, oops, not that, sorry. And there, right? So let's walk through this. So if there's a record, great. We'll go ahead and load it up, load their emails. What if there's another record?
What would that be? Another email?
Yeah, no, well, another person. Two people with the same ID. Can that happen, first of all?
No.
No, why? Because we designed our database well. It's a primary key over here, right? Now over here, of course, it's a foreign key, so of course it's going to appear more than once, right? And all those records, those 5 email records, refer back to the same person. So no, this is not possible at all to have multiple people with the same person ID because we have proper data integrity in our database. You could, code and say, well, okay, what if the database folks were idiots and they didn't do that? Then go ahead and code defensively against that and then throw an exception. Something really wrong happened with the database if you don't trust them. But we have access to the schema here. We know that that can't go wrong. Right? Okay, so I'm convinced that that's not a possibility. You asked for something that doesn't exist, so we'll go ahead and throw it back at you. Right? If you really, really want to make sure that it's true, then if rs.next, right? Throw new really illegal state exception. Your DBAs changed something and are idiots. Right? Dot, dot, dot. There we go. Do it after all of that stuff. Right? Really illegal state exception. That's why I'm not going to leave it in there. Right? So think about how this is your, this is going to end up being your API. Not in this phase, but in the next phase, phase 4, you're going to be writing an API for your database. And everything will be your decision how you load stuff up. Do you want just one function to load up everybody, right? Do you want a helper function, like load emails, to load up an email so that you don't have to put it all into one big giant thing, right? So that you don't have a method that is 1,000 lines of code. Do you want some additional helper functions here that loads up a person by ID, or loads up an email by person ID, or something like that, right? That's all up to you, okay? This is the database data loader. Let's look at how we can make another class here. Data save. I don't want to call it saver, but I will. Right. There we go. Data loader, data saver. Right. So how do we get stuff programmatically into our database? So let's go public void insert person record. I'll just go with insert person. Right. And we'll have a person P here. Right. So you give me a plain old Java object here, right, person P, that has no connection to the database, and I want to insert that person into the database now. Over here, I already have a person set up, Jane Smith. Now, when I've created her, I've created the first name and the last name here. By the way, are we requiring a date of birth? Looks like we are, so maybe we need to do something about that. But in any case, we'll fix that later here. I'm adding a couple of emails here. I'll go ahead and P1 here, P1 there. So I'm adding a bunch of emails to her, but what about that person ID? Right. So should I be hard coding that to some value like, say, 42? That person doesn't exist. We're good. Or should we let the database take care of it with that auto increment? I like that solution a bit better. Right? We will insert the first name, the last name, and because we have to, the date of birth. We will also be inserting all their emails. Right? So how do we get stuff into the database? Same basic steps. Create a connection, prepare your statement, execute your statement, but you're not necessarily going to expect anything back because it's not a select statement. It's going to be an insert statement or a delete statement or an update statement. Okay?
Is there like a pass-fail that it will send back? Or?
That's a good question. We'll get into that by the end here. Right? So I'm going to go ahead and just as a start here, let's go ahead and load this up. Data saver, right? By the way, we don't call it saving data, we call it persisting, right? Persister. Why? Because we needed a fancy word to set it off. If you persist, what is it called? What does that mean? You continue, you stick with it, grit, whatever, whatever they want to call it. But I'll go ahead and call it saver, right? Data saver. I think we give you a class. This is now the 5th phase. We give you a class, and so you don't have to figure out what to name it because we give you the name. Right? You're going to be basically doing this in the 5th phase. Okay, so once again, I've cut and pasted a whole bunch of code that probably should belong in its own class. Right? It's no longer a select statement, is it? What is it going to be? Well, that's why I'm going to go over to Workbench here and troubleshoot it. Right? And I'm going to write the query to insert a person over here. In fact, I've already done that. Right? Insert a person. Let's go ahead and cut and paste that. And I only want one person. Right? Let's take out all the white space because that's not going to look very nice over in Java. So first of all, do I want to specify the person ID now? No. Again, let it take care of it for you. First name, last name, date of birth. How did I design this? Date of birth? Oh, okay, so we don't have to put it in because the default will end up being 0000000. Okay? But I will. Because when we pull that out, it will, and we try to parse it, it's going to throw an exception because that's not a valid year. Okay? These things are not going to be hard-coded to those strings. Instead, what I'm going to do is I'm going to go question mark, question mark, question mark, because I'm going to parameterize those things. All right? Now let's bring this over, and there's our query. Oops. Get rid of that superfluous one right there. Now, if you've got a really, really long query, the great thing about the multi-line strings in Java is that you can put them into multi-lines. There we go. And multi-line. There we go. So if you wanted to break this up, like you did over in the SQL file, that's fine. You can go ahead and do that using a multi-line string like this. The issue gets into, well, is that the way that you want to indent things? Like, I mean, what would the Eclipse even do in this case? That's what Eclipse does. Leading spaces are ignored in multi-line strings, and so that's a little bit better, easier way of looking at it with multi-line strings. Right?
What's the format shortcut?
This is Mac,
Okay.
so Shift Command F. I believe it'll be Shift Control Shift F. All right, there you go. All right, so we've got three things to set now. Okay, the first one is going to be ps.set. String, and the first one is 1. And it'll be p.get first name. The second one and the third one are all going to be strings as well. p.get last name, right? First name, last name, date of birth. And do I have a getter for that? I don't think I do, but get date of birth. That's all right, because now we're going to refactor our class over here. Right? We've got a date of birth. Let's go ahead and force people to add it. Local date of birth. There we go. And this dot date of birth is equal to date of birth. There we go. And I don't have a getter for, oh no, I have a getter for it, local date. So over here in my demo though, I'm going to have to create so local date dot of, Jane Smith was born yesterday. So 2023, 03, 22. There we go. Okay. All right, so set string, date of birth, oops. And then we need a toString. There we go. All right. I believe that the default is to use ISO 8601. We're good to go. Why is that the default? Because that's the correct way. All right, we've set that. We execute that query, except that it's no longer a query that we're executing because we don't expect a result set back. So I'm going to go ahead and get rid of the result set entirely here. We're inserting data. So let's execute my query. ps.execute. It's not execute query, it's execute update. There we go. And again, I'm not expecting anything back. So I execute it, I update, I close it, and I close the prepared statement, and I close it. All good? Let's come over here to the demo and run it. Oops. What's not compiling? Oh, okay, so date of birth. There we go. What else is not compiling? Oh, and then date of birth. Birth. There we go. All right. Now let's go ahead and execute this. Uh-oh. You asked for something that does not exist. Oh, I did end up throwing that exception. So let's go ahead and get rid of that. There we go. And run this again. There. So I inserted something. Do you expect anything back? No. But now let's go over here to MySQL Workbench and see if it was successful. Nope. Oh, did I? Oh, probably because I didn't call it, duh. That's why. I didn't think that there was an issue. Data saver dot, oops. Is it not public? Public static insert person. Screwing up all over the place today, unintentionally today. P, there we go. All right, now let's run this and it should work. There we go. And get rid of this and select everything from person now. There we go. We've got Jane Smith in there. You'll note that her person ID was automatically generated to be 51. There's Jane Smith, and she was born yesterday. Okay. What do you think would happen if I ran this again? First of all, Jane Smith would be in there now, right? So when we list everybody, she'll be there. But when I run this again, oops, let's come back over here and select everything from person. Jane Smith is in there now twice. Right? Because you didn't give any unique characteristics of Jane to distinguish between that first Jane and the second Jane. Right? So if this is the behavior you want, we're good. You keep adding Jane Smiths all the time if you want to. There's no way for me to distinguish between those. But what I could have done is I could have checked to see if that person already exists. Right? So in the data saver over here, what I could have done is 0 error handling. Check to see if the person exists already using some criteria. The way that I've designed this database, I don't have any criteria by which to decide that. Right? If we had some sort of natural key of a person, for example, a social security number or an NUID or something like that, then we could check against that. Right? No, the person with this NUID already exists, right? And we'll go ahead and reject that. Right? So the way that you could do that is by going back to your data loader. Right? Person P exists, I don't know, is equal to data loader dot get, oh, not data loader, database data loader. Right? Again, I'd have to instantiate it. I would have to then load that person by ID. Right? So it would look something like this. Dot load person by ID, P dot get person ID, right? And if P exists is not equal to null, then, I don't know, throw an exception, return a dummy value, do whatever you're going to do with it. Right? Right. So basic error handling, if you want to if you want to do something like that, right? Just check. Is that already in the database based on this criteria or that criteria? And if so, then don't do anything. That means that maybe I want to change the return value here to an integer. What could that integer indicate? Attempts to insert the given person code into the database. If successful, it will return the auto-generated primary key value of the new record, right? If unsuccessful, it will return, say, I don't know, 0. Right? That's why using 0 as a primary key for anything is not good. In fact, I'm going to change that even further. It'll return, say, null. That's going to be way better. And we'll change this to big I integer. Right? Because there's no ambiguity there at all. There. So you give me this person. I'm going to go ahead and insert them into the database. If it didn't work, what I'll do is I'll return null. Right? If I'm doing this, basic error checking here. But the problem is, if it's successful, I want to return that brand new primary key value. Right? In other words, I want to return 51, 52, 53, whatever it was that was generated. How do I go about doing that? If I'm executing an update, it doesn't really return anything. It actually does return something, int, right? What's the return value? Either 1, the row count for SQL data manipulation language statements, or 2, 0 for SQL statements that return nothing. Right? In other words, don't read anything into that return value. Right? So what we need to do is we need to do this slightly differently. Right? And for that, I'm going to have to look at my code. Yeah, there we go. All right? So we've got an insert statement here. We prepare the statement, but when we prepare the statement, what I'm going to do is I'm going to add another parameter here. Statement.return generated keys. And what that does is it directs the statement that you're going to insert this data, but you're also going to do some extra work for me. You're going to go ahead and give me the key that was generated on this insert statement. And we're only expecting 1. Right? But if you were doing multiple inserts, you could expect multiple. Like if you were doing something like we did over here, right, where we're inserting 4 people at once, then you're going to need 4 keys back. And that's why it says get generated keys. But we're only interested in 1 in this case. So we set all this stuff. We execute the update. And then we have a result set. Results set. Now we do get something back from the database. I'll call it keys. Right? PS got get generated keys. I'm only interested in 1, right? So keys.next. Right? And then int key is equal to keys.getInt. And it's just one thing, so we're just going to get it by its index.
What's the next for?
That's, remember the result set? If I've got 5 things, initially it's pointing before the first one. So I need to get it started. True, 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 false, right? And you could put this sort of if keys.next and then do it like this, just to make absolutely sure that it worked. But if it didn't work, it would probably result in an SQL exception and you don't need to worry about it. Throw new illegal state exception. Right? Something went wrong. Right? Otherwise, we've got our key right here. I'm going to keep it simple and just assume that it came back with the correct value. So keys.next. There we go. That's the value that I want to return. Should I just immediately return that? Return key right there. Int. Well, first of all, the compiler is warning me this is dead code. This is unreachable code. Why? Because you're returning right here. Right? So, no, that's not where it belongs. You need another value up here, integer, key value, or inserted key value. Right. Initially, it's equal to null. And down here, if it's successful, let me grab the value there, then inserted key value will get set to that thing. And down here, after we're all done, we return whatever that is. If something went wrong in this entire process, this will end up being null, because that's what we initialized it to. Now let's come over here to the demo and get that value. Int, or integer, x is equal to this, and then system.out.println x. Run that, and we see that it's now 53. If I ran this again, what would you expect it to be? 54, 55, 56, right? And let's take a look at all the people. Now we've got a lot of Jane Smiths, right? So whether or not you intend for this to happen, right, you need to be more defensive about it, okay? Why would that help us, though? Does she have any emails? Let's go ahead and select all the emails from, say, that first one, 52. She didn't have any emails, even though I had emails over here as in my POJOs, my plain old Java objects. Did we insert them? That's a different table. We inserted the person, but what did we not insert? Their emails. That's great because I've set myself up for this, right? Remember that when we insert the person, we also get this person ID, which we need to insert the email over here. So let's come back over here to Data Saver. All right. Once we've inserted that person, then we can go ahead and insert now insert their emails. ... So for each email, for string s email in person.getEmails. Oh, do I not have a .getEmails either? Oh, all right, fine. Add email. All right, so I don't want to write it. Generate getters, emails, done. There, get emails. All right, there, now I've got email. For each email, let's insert the email, ... Note here that I'm already done with my prepared statement. Once I've executed that update, inserted the element, gotten the key, I'm done with it. But I am not done with the connection because I'm going to use it right here. So let's create a new query. Right? Insert into email. Right? And what do I need for email? I need an address and a person ID. An address and a person ID. Values, and then a question mark, question mark. There's my new query. I'm just reusing the string variable up here. Right? I can reuse that prepared statement. PS is equal to con.prepare statement query. Now, do I need those values back? If I had an email class, I would, right? Because I would those would automatically be generated, and I'd need to put those into the email class to be able to have them, or I could just reload them or something like that. But I don't need those IDs, right? So I'm not going to bother grabbing the generated keys here. Right? PS. Actually, I don't need to do this sorry. I'm going to move this up here. I don't need to reset the query and prepare the statement for each possible email. So instead, what I'm going to do is I'm going to ps.set, not set array, but set int. Let's see, it's address and then person ID. So it's actually ps.set string. The first one will be the address, so email. Oops. There we go. Come on, there we go. And then the second one is the actual person ID, so person, which I've got where inserted key value right there. Okay. And then ps.execute update. There. So now again, let's go over this. Right? So I create my query here to insert a person. I create my connection. I prepare my statement with the intention of grabbing that person ID auto-generated. I set my first name, last name, date of birth. I execute that update, and I get the generated key. Now I know that Jane Smith is at 51. Right? I close that because I'm done with it. But I'm going to reuse that variable right here to formulate another query. Right? I prepare that statement. I set each one of these values here, which is the address and the person ID. What I initially started out doing was I put these into the loop. Do those change at all? No. So they don't belong in the loop. In fact, this is one of the advantages of using a prepared statement. It's actually more efficient. Once you've prepared the statement, you can reset these values really, really easy. Set it for the first email, the second email, the third email, the fourth email, etc. It's actually really, really efficient to do this and then execute each one of those updates. Let's come back over here to demo and see if it works now. J Smith and J Smith at Gmail and then unomaha.edu. Right, so let's go ahead and come over here and just check it out in the MySQL Workbench. The last one that I inserted was 57. So let's check her out, all of her emails, and there we go. Now we've got J Smith and J Smith at UNOmaha. If I ran it again, of course, I would end up inserting yet another record, but then we can see that that record actually does have emails right there. Right. So pulling stuff out of the database, putting stuff into the database. As a wrap up, let's talk about best practices. Sorry, just a second. Okay. So best practice 1, avoid the star operator. Right? So remember when we did something like, for example, don't do select star from person, right, in JDBC. Why? Because what if you're not going to use all that data, right? This sends all data over the wire, right, network, whether or not you are going to use it. Network is the most expensive bottleneck in any computing operation, right? The processor is super fast. The server is super fast, even faster. What is going to be the bottleneck between these two things is going to be the slowness of the internet connection, the network connection. You've seen it actually, right? That this actually does take a while. Like it's a perceptible amount of time because it's going back and forth between Lincoln. Now you can imagine if you've got a very slow internet connection, why are you sending over, say, the person ID and the last name when you're not actually ever going to use it? Right? If I just use select star, then that sends everything over the wire. Be more intentional, right? Only select the columns you are actually going to use. Yeah, I spelled that right. For example, if I come over here and I say, select everything from person, P, let's zoom in here. Person P, join, and you can do joins, right? What we did is we separated those two things out into a person and an email phase, and we did that very, very intentionally because of this problem. Select a star from person P, join email E on P.person ID is equal to E.person ID. There we go. Now, good old Don here, he's got 3 emails. Why are you going to send Donald, Donald, Donald 3 times over the wire? Right? That's why I separated them out into 2 different functions, so that you're not sending superfluous data over the network. Not only that, but we've got some repetition here, right? Because we joined on the person ID and the person ID, we've got the person ID right here, and we've got the person ID right here, even though they're the same values. Why are you sending 10 over the wire twice? 3 times, 4 times, right? That's your bottleneck. Be way more intentional. Only select the columns that you are actually going to use so that you are not sending redundant or useless data over the network. All right, it also future-proofs you. Right? If someone comes in and adds a new column with a lot of data, we call these things blobs, right? Binary large objects. In other words, somebody comes in and says, oh, you know what? We need to start storing people's image photos so that we can see that, like, you know, I can if you've opted in, I can see your N card, or what you call MAV card photos on Canvas or something like that, right? What if somebody comes in and changes the person table so that we're storing that image right there, and we're using that select star, even though we don't end up wanting the image at all? Those megabytes of data now come over the wire, right? And it becomes super, super slow. It future-proofs us because if there's some DBA out there that ends up changing it and adding a whole bunch of columns that we never actually use, but we're using select star, then that means that we're wasting a lot of bandwidth. Right? It gets really, really slow. Right? Security issues. So for this course only, we are storing passwords in a plain text in a Java source file. Don't do that, right? This is unfortunately common. Right? And in fact, it's so common that many researchers have gone through public GitHub repos looking for variables called password or passwd or pass or something like that. And guess what? Developers aren't that great about security. They will actually check their password into GitHub, right? And they've found thousands and thousands and thousands of these things. So unfortunately, it's quite common, right? For this course, of course, use passwords you do not care about, right? Because we don't have access to a full server. But in practice, what you do is you define what's called a data source, a passwordless, headless operation, basically. In other words, there are 2 ways that this can happen. One way is that you can go ahead and start up the server, and when the server starts, it prompts somebody physically to enter in a password. Once they've entered that password in, it's good to go. right? It's stored in memory. Presumably nobody has access to that unless you have access to actual raw memory. And you saw that what happens when you do that in C, right? You try to access an arbitrary memory location, segmentation fault, right? That's a good security thing. If there's not a good security around that, then of course you could do that. But once you entered the password, it exists in memory, right? Now, if the server ever goes down and the RAM gets wiped, then somebody has to come in, start it, and enter the password again. That way, you're only ever storing the password in one person's head. Right? Another way that you could do this is by setting up a proper network policy, where you say, that application server over there on that IP address can go ahead and make database requests to this database server over here with this IP address. Everything else gets firewalled out. Nobody can talk to this server at all unless they're that server coming on that port 3306. Right? And once you've locked everybody else out and you trust that server, then you don't need a password at all, right? Because it's a network thing. Right? Network policies, firewalling is also an option. Right? It's not an option for us because we've got firewalling is not a word. Yes, it is. Fine. Firewall, right? Firewalling should be a verb, right? I don't know. Anyway, once you've got I mean, we can't do that because it's it's an education server, and we've got too many students, needing access to it to firewall it off. The next best practice that I'll mention is close your resources. There we go. Failure to close your resources wastes them, right? You may run out of connections. Once you hit that 30 connection limit, that's it. The show is over. And you might have to be sitting there for 5 minutes until everything gets reset. So make sure that you close them in the proper order. And unfortunately, there is not a good way that I can give you to troubleshoot this. If you've got, like, say, 20 methods that all open up a connection, right? And you don't know which one you screwed up on and didn't close, there's not an easy way to go to the server and tell what query was it that didn't get closed, right? There's not an easy way of troubleshooting that. There are better solutions, but that goes beyond the course of this, beyond the scope of this course. So my suggestion to you is when you write a function, you rigorously test it, right? Before moving on to the next function. Make sure that you're always closing your resources. We've already seen this one, but make sure that you are handling those SQL exceptions. Those SQL exceptions must be dealt with because they're checked exceptions. Just catch and release. Catch, rethrow it as a runtime exception. You may want to log an error and then rethrow it, and you can do that. If you do logging, do not use system.out or system.error. They're not proper logging libraries, right? And the reason is because nobody's sitting there watching the screen waiting for something bad to happen. Oh, I'll jump into action now, right? Nobody's sitting there watching the standard output or the standard error. What you want is a proper logging system where events, not necessarily bad events, but like this person logged in at such and such date. That person updated their record at such and such date and time. Information, right? You can also have warnings. You can have errors, and then the lowest level, of course, would be just debug statements. And you can do this with a proper logging library. The one that we suggest that you use is log4j. I can show that to you maybe next week, how to use it, and using it in your future phases is worth bonus points if you want to use it. Right? But you do not generally use system.out because there's nobody sitting there staring at it. Instead, what a proper logging system can do is it can take all of those log error messages or log information messages and put them into a file or a database. Or when something really bad happens, like an error, it can shoot off an email to a sysadmin. System.out can't do any of that stuff, right? But this proper logging system has a lot of configuration, a lot of bells and whistles, and a lot of features that would allow you to do stuff like that. Right? Okay? Log4j is what I would suggest. Another best practice here is the last one that we've already talked about. Always use prepared statements. In fact, I don't even show you unprepared statements. There are statements, there are raw statements. Do not use them. Do not go out to awesomejavatutorial.com and get these terrible code samples that use unprepared statements. You'll lose points on design. And that's because of SQL injection attacks. If you want to see a SQL injection attack in practice, do the extra advanced activity on lab 10. I've set up an SQL injection honeypot on the CSE server. If you change your database a little bit, and then you go in and you insert a particular record, what you can do is you can inject HTML into the web page that you build. Hopefully it works. Hopefully it still works as a web page. And then what you do is instead of listing all these albums, what you do is you have list all the albums, and then you end the table, and then you have this little I think link down at the bottom that says please click here to re-log in, right? And it takes you to another website in which I'm grabbing your password. So don't fall for it and actually enter in a password. But it shows you how it can actually be used to, that's kind of a cross-site scripting attack too, in a way, but not exactly. But it shows you how SQL injections actually work. Right? Never, ever use anything else. As far as you're concerned, nothing else exists. Right? You always use prepared statements. It's just simpler too. Just use one technique. Oh, that one doesn't need a prepared statement, I'm pretty sure. That one may or may not. That one definitely does. Why go to that guesswork? Just use one thing, prepared statements, right, and be done with it. It's actually more efficient too. Okay. All right. Any questions? Go ahead.
Wasn't there a vulnerability log 4J that was?
Oh, good. Oh, whoa, you've got a memory. Yes. Log4j vulnerability. Wow.
You could inject arbitrary code.
Yes. What it is, how it was fixed. It was only on a server, and you're not running stuff on a server. When was it? It was like a year ago or so? Yeah. So just last September. Well, arose in December of 21. So yeah, it was over a year ago. If you want to read all about that, basically, yes, it allowed you to log stuff to and if they logged it to like the system.out or something, you could run arbitrary shell commands or something. I forget, or maybe it was just a DOS attack. I don't know. We're not. How does it work? Oh, okay. It looks like maybe it was a JNI attack or something like that, where maybe. I'd have to read about it. I forgot about it. But yeah, wow, excellent memory. How'd you remember that? Had you used Log4j before?
No.
No, so you haven't even heard of it, but you remembered the.
I heard of it.
Because it made the news or something like that. Okay. All right. Otherwise, if there are no questions, your lab 8 is due by midnight. That has you creating some tables and concert tables and putting in some data. Right. Oh, and then of course your design document for this week is due Friday by midnight too.